Okay, so this is your chapter of MA 112, okay, area and perimeter of plane figures. Okay, so essentially you're gonna learn some formulas, okay, for area and perimeter of some of your common figures, okay, like trapezium, your circle, your sector. Okay, so before we go into that, let's take a look at the conversion of units, okay, because sometimes in the questions they like to ask you to convert the units, okay, for the area itself. Okay, so first you have cm square to meter square. Okay, so we all know 1 meter is equivalent to 100 cm. Okay, so first and foremost, before I can do the conversion, I need to find out, okay, what is the equivalent of 1 meter square in terms of cm square. Okay, so when I have 1 meter is to 100 cm. Okay, when I want to convert them to area, which is square, okay, I will square the entire term, inclusive of the number itself. Okay, so 1 square is 1, meter square is just meter square. Okay, 100 square is 10,000. Okay, then you square the cm as well. Okay, that is how you get this value of 1 meter square is to 10,000 cm square. Okay, then because you want to find out how much is equivalent to cm square in terms of meter square itself, okay, you just divide the 10,000 over. Okay, so for example, okay, 1 meter square equals to 10,000 cm square. Okay, you just bring the 10,000 over, you get 1 cm square equals to 1 over 10,000 meter square. Okay, that's it. Okay, just that in the notes, they flipped it directly. Okay, but the steps you follow are the same. Just divide the value over to make it 1. Okay, meter square to cm square is just the swap of it, which is essentially what you just worked out at the start. Okay, to square both the meter and the cm, okay, you get 1 meter square is equivalent to 10,000 cm square. That's it. Okay, so same thing as what I did for you earlier. You bracket the entire 100 cm and you square it. So 100 square you get 10,000. That's it. Okay, so you have an example here. Okay, so it will be good if you can commit this conversion of area from cm square to meter square as well as meter square to cm square to memory. Okay, but if you can't, okay, it's okay. Just work it out as how I did at the start for you all. Okay, it's the exact same thing. So if I want to convert cm square to meter square, okay, all you do is multiply the value by 1 over 10,000, or you divide the value by 1 over 10. You divide the value by 10,000. Okay, but if I want to convert meter square to cm square, which is what you have for example part B, okay, multiply the value by 10,000. Okay, so I believe A and B shouldn't be an issue. Okay, the only problem that most students have is normally the conversion of units. Okay, so if you cannot you cannot remember, or you cannot commit it to memory, convert it on your own like that, like what I just did. Okay, it won't take you too long. Okay, can? Okay, let's look at the area and perimeter of your shapes. Okay, so essentially some of the formulas they need to commit to memory. Okay, so previously you should have learned the area and perimeter for all of these figures here. Okay, these first four here. Okay, your rectangle, your square, your triangle, and your parallelogram. Okay, so we're just going to do a short recap here. Okay, rectangle, your area is just length times breadth. Okay, then rectangle, obviously the length and breadth are all equal, right? The respective length and breadth. Okay, so that when you see all these dashes, it means these two sides are equal. Okay, then you have double dashes to represent a different length. Okay, perimeter is just the sum of your length and breadth, your two lengths and breadth. That's why it's 2 times of it. Okay, square is just length times breadth as well. Just that for a square, all sides are equal. Okay, your perimeter is just 4 times of the same length. Okay, triangle. Okay, half times base times height. Okay, where base is the base of your triangle. Height. Okay, this height is your perpendicular height of your triangle. Okay, so this H here represents perpendicular height. Okay, write it at the side. Okay, in case you forget. Okay, so if this height is not perpendicular, or the length you are using is not perpendicular, you cannot use it in the formula. Okay, so when I say perpendicular, it means when I draw the straight line down, okay, it should be 90 degrees, a right angle. Okay, perimeter is just the sum of the sides of the triangle. Okay, and then last but not least, your parallelogram. Okay, so your area of your parallelogram is basically base times height. Okay, essentially it is like a rectangle. Okay, why? Because if you can imagine this triangle here that I'm dotting out, or not say dotting out, that I'm drawing out, if I replace it with this triangle here, which is equivalent to it, essentially what you are looking at is a rectangle as well. That is why the area or the formula of the area is base times height. Okay, essentially it's length times breadth of a rectangle. Just that now parallelogram is presented in a different form. Okay, so same thing. This height here, this is your perpendicular height. Okay, that's why you see a 90 degrees here. Okay, then your perimeter is just the sum of your length and breadth of your parallelogram. Okay, then recall for your parallelogram, opposite sides are of equal length. Okay, same thing, opposite sides are of equal length. Okay, this single arrow and double arrow here just represents that. Okay, this line is parallel to this is parallel to this, that's it. Okay, so these four figures shouldn't be too foreign to you, something that you have learned before. Okay, next, let's take a look at the other three that we have here. Okay, so firstly you have your trapezium. Okay, your area of trapezium, okay, is half times A plus B times your perpendicular height. Okay, so whenever you see the H in the formula list, this always represents your perpendicular height. This A plus B itself, okay, if I put it in terms of words, this is sum of parallel sides. Okay, your sum of your parallel sides. You see the two arrows here, right? It represents that these two lengths are parallel. Okay, so half times A plus B times height. Okay, perimeter, quite standard. Okay, just sum up the four different lengths. Okay, this is for your trapezium. Okay, circle. Okay, this one shouldn't be new to you all as well. Okay, your area is just pi r square. Okay, just think note for your pi. Okay, sometimes in the questions they might specify a value. Use pi as 22/7 or use pi as 3.14. If they state that, you must use the exact value of pi. If not, just key pi into your calculator as you always would. Okay, next. Okay, your perimeter, which is essentially this is your circumference of the circle. Okay, so it's either 2 pi r or pi d. Okay, why pi d? Okay, cause 2 times r. 2 of your radius equivalent to your diameter. Okay, so it's expressed in either form. Okay, so just remember it as the form that you are more familiar or comfortable with. Doesn't matter. Both are mathematically correct. Okay, lastly, we have your sector and your semicircle. Okay, so let's look at sector first. Okay, so sector is essentially a portion of a circle itself. Okay, so within a circle, okay, one round, the angle is 360. Okay, this is an example of a sector in a circle, which means a portion of a circle. Just you can think of it like a part of a pizza. Okay, a slice of pizza inside your circular pizza itself. Okay, so if I want to find the area, okay, essentially I'm finding an area or a chunk of the circle itself. So your formula is theta, which is the angle value here, over 360, which is the entire angle of a circle. Okay, times pi r square. So this pi r square is the area of your circle itself. Okay, so what you can visualize this as, okay, I am taking a chunk of the circle. And what is the ratio of the chunk that I'm taking? It is the angle over the 360 degrees, which is the total angle within the circle itself. Okay, times pi r square. So essentially this is a bit like a ratio type of formula where I'm taking a chunk of the circle. Okay, then for your perimeter, okay, so for your perimeter, what you are calculating for a sector is this curve length here, which is a portion of the circumference of the original circle plus the two radius here. Okay, so same thing, I'm also taking a chunk of the circumference of the circle. That is why you are still taking a ratio of it, which is theta over 360. Okay, where theta is the angle of the sector itself, times 2 pi r, which is circumference of the circle. Okay, which is this portion here. Okay, then lastly, you just add up the two radius at the side. That's why it's 2r. Okay, then lastly, you have semicircle. Okay, this one should be quite straightforward. Okay, this one, your area is just half of your area of circle, right? That's why it's half pi r square. Okay, but for your perimeter, okay, you have an additional portion. Okay, so originally your circumference of your circle is 2 pi r. So since I'm taking a semicircle which is half, okay, my circumference that I'm accounting is only pi r, because 2 pi r divided by 2. Okay, the 2 will cancel out. That's how you get pi r. And then you have to also add into account the diameter of the circle, which is 2r. Okay, or you can simply put it as d. Okay, that's why same thing, there are two ways of expression. Okay, in terms of radius or in terms of diameter. Okay, based on what the question gives you. Okay, so these are all of the formulas for area and perimeter that you need to know. Okay, this 8 diagrams in total.